All right, welcome to the online lecture for successive percent change. So this is going to be just a brief review of what we know about percentages. And we'll talk about how a lot of what we've already learned, the percent change formula, exponential change, some of these general percentages questions, they can all really be used to answer the same basic kinds of questions. And then what we'll do is we'll talk about what does this mean when we have multiple percent changes, right? So if we're talking about a single percentage, we can use what we've learned so far, and we're going to learn a new thing when we talk about multiple percents. So say for the sake of example that it is the 1990s and you are out shopping for jeans and you are interested in buying a pair of Hollister jeans. They are $100 and they are on sale for 40% off. So one way you can answer this question would be by multiplying the percentage as a decimal times 100, and that would get us $40. And then we could subtract that from the original price. And this is how probably most of you would have answered this question coming into this class. But we could think about this in terms of percentage change, right? So we have some new value, some new cost of jeans. We don't know what that is. But we know the old value is $100, and we know that it's going to be a 40% decrease. And when it's a decrease, we can think about that as being negative, right? So with this, then we can do some algebra to solve for the new price. So step one for the algebra, we're going to divide both sides by 100. And that will, multiply both sides by 100. The multiplication will cancel out over here on the left. Then we'll have negative 0.4 times 100. And then it's pretty straightforward algebra. We add 100 to both sides after we do that multiplication, and we end up with 60. Okay. Again, should be review of algebra. There will be a tiny bit of algebra in this week's activities. You could also, again, so the new minus old, not the ideal way to do this, right? But it's possible. You could also use the exponential change formula. Remember, we talked about this as simple percent change. So we would plug in our rate change, which would be minus 0.4, as our R. Our starting value is $100. 100 times 1 minus 0.4, that gets us $60. Now, I think I mentioned this with exponential modeling. I like this as the simplest way to answer this question, because it only requires one step. Instead of multiplying by the percentage and then subtracting, you just add that 1 plus or 1 minus and you can get it all in one step. What is also cool about this formula is that this formula allows you to solve for any of the variables that are unknown. So if I tell you, for example, you went to the store, you paid $60 for some jeans, they were 40% off the original price. What was the original price? Now what I'm giving you is I'm giving you the final value, this Y, and I'm giving you the percent change, the minus 0.4, but I'm not telling you what the starting value is. So you have to work backwards. And again, pretty straightforward algebra. 1 minus 0.4 gets me 0.6. And then divide both sides by 0.6, and that will get me 60 divided by 0.6 is back to that 100. Okay. Now, let's say, for the sake of argument, that you decide to buy the jeans, and you get up to the counter, and the clerk says, "Oh my God, did you know that today you can get an additional 20% off the sale price, and all you have to do is sign up for a Hollister credit card?" Right? You have to sign up for a store card, and you have not had the credit card lecture yet in this class, so you don't know what a terrible idea that is. Sidebar, the interest rate on that credit card is probably 30%. So if you don't pay the bill off in the first month, they've already made 10% in interest on you beyond the 20%. Anyways, sidebar. Right? We'll talk about that with credit cards. So it's 40% off plus an additional 20% off. So the question is then, okay, now how much are you going to pay for the jeans? So based on what you know now, what we would do is we would go step one, 40% off of 100. 100 times 1 minus 0.4, so that's 60 when we walk up to the register. Then we're going to get an additional 20% off. So we would plug in that 60 as our starting value and take 20% off of that, and we would find that we would pay $48 in total for the jeans. Now the next question is, what is the overall percent change? In other words, you start at 100 and you end up at 48. What is the overall percentage change? Now, for those of you who are a little bit clever, you would probably come to the answer of 52% because I'm using nice, easy numbers like 100. But in order to solve for this, right, ideally, you would use the new minus old formula, right? So we'd plug in our new value of 48, our old value of 100, right? 48 minus 100 divided by 100 would get us to 52%, okay? Now, why isn't the overall percent savings 60%, right? Why can't you just go, well, if it's 40% off plus 20% off, so it must be 60% off? And the answer is because that 20% off is not coming off of the original $100. It's coming off of the already reduced price. So you can't just simply add these percentages together. Now, again, based on what you know now, you would have to do this three-step process. Step 1, change it by 100. Step 2, change it by 60. Step 1, take 40% off of 100. Step 2, take 20% off of 60. And then step 3, you'd have to calculate that overall percent change. Now, another way we could do this, and again, I'm not saying that this is the best way to do this, but one way we could do this would be to plug this into our exponential change equation, right? We have some starting value, it's 100. We have some final value, it's 48. We don't know what the percent is, but we know that it's negative because it's a decrease. And so what we could do is we can solve for R. Now, this is a little bit of like, junior varsity algebra right here. But the trick to doing this is to know that you can rewrite this equation 100 times 1 minus R in parentheses. You can distribute that 100 times into that parentheses. So 100 times 1, and that goes here. And then you can do 100 times R, and that goes here. So you end up with 48 is equal to 100 minus 100 times R. And once you have it in that form, then it becomes pretty easy algebra. But again, ideally, you'd probably just want to use that new minus old formula. Okay. So when we talk about successive percent change, we're talking about any time there are two or more intermediate increases or decreases by some percentage. So in this case, there were two intermediate decreases. Now, if it seems like that was a lot of work to get to this 52%, right? So we'd have to take the price and decrease it by the first one, and then take the price and decrease it by the second one, and then we'd have to calculate that overall percent change. If that seems like a lot of work, I think that you would be right. There is actually an easier way to do this. And it's using what we call the successive percent change formula. So we take 1 plus or minus the first percent change times 1 plus or minus the second percent change, all minus 1. Now, importantly, you must remember minus 1 because everybody forgets minus 1. This is like including the total in the pie chart. You remember the first part, but not the second part, and your answer is all weird. Okay, so don't forget the minus 1. So going back to our original question. So if you started with this question, you said the jeans are 40% off, you take an additional 20% off. What is the overall percent change on the cost of those jeans? 1 minus 0.4, or if we're doing this in Excel, you could literally type in 1 minus 40% times 1 minus 20%, all minus 1, and we get 0.6 times 0.8, all minus 1, which just gets us negative 0.52. And we calculate this 52% decrease. Now, what's wild about this is that when we did this calculation, as you may have noticed, we did not include any information about the cost of the jeans. And this is because the cost of the jeans doesn't matter. I mean, it matters to you if you're buying them, but it doesn't matter in terms of the overall percent change, right? The percent change doesn't depend on the starting value, right? If you are taking 40% off and an additional 20% off of a multi-billion-dollar yacht, it's still going to be 52%, the same as if you took 40% off or 20% off of a $10 bottle of Windex. I don't know why Windex would be $10. That's a terrible example, but you see what I'm saying, right? The overall percent change does not depend on the starting value itself. Also, this formula is not limited to only 2% changes. So you can keep adding percent changes to this. So I could do 1 plus or minus R1 times 1 plus or minus R2 times 1 plus or minus R3 times 1 plus or minus are 4. You can just keep adding them as long as you remember to add minus 1 at the end, because that's what makes the whole thing work. So now, if we were doing this in the get-go, if this was the question, the jeans are on sale for $100 off, the jeans are on sale for $100, they're 40% off, and you gain an additional 20% off if you apply for the credit card. And I say, what's the overall percent change? How much do you pay for the jeans? We would be able to answer all these questions using what we've learned so far. Step 1, use the successive percent change formula to figure out the overall percent change. Step 2, once you know this, you can solve for that final price using the simple percent change formula, 100 times 1 minus 0.52. Okay? And given any two variables in this equation, you can always find the third. And asterisk, there is a fair bit of mental gymnastics, JV algebra in this week's activities. But if you give them a try on your own, you can bring them to class when we meet again, and there will be time for me to go over and help you out with any rough spots. All right, so to go through and do an example then, and I'll do this with you guys. So to go through and do an example, crude oil prices are volatile. Typically, oil is subject to the basic laws of supply and demand, right? So like most commodities, consumable goods. So when the supply stays constant and demand goes up, the price goes up. When supply stays constant and demand goes down, the price has to go down. And the same thing happens on the supply side. So if demand stays the same and supply goes up, there's more of it on the market, then the price of that thing goes down. If demand stays the same and the supply goes down, there's less of it on the market, the price goes up. So in the 1990s, oil was trading at about $15 a barrel, 1998. And there was a big decline in demand in the Asian Pacific markets. And so the crude oil prices dropped 28%. So they went down 28%. Now, OPEC, which you may or may not know, OPEC is a group of oil-producing countries in the Middle East. They get together and they set their production limits. And for a very long time, up until very recently, could basically dictate the price of oil around the world by changing the production. So they could increase their production to bring down the price of oil, or they could decrease their production to bring up the price of oil, depending on what their goals were, sort of geopolitically. They don't have as much power these days because of U.S. producers, or at least where I sit and recording this in 2019. But they still can affect the price of oil. So in the 1990s, OPEC cut production by 106%, and this led to a dramatic increase in the cost per barrel from 1999 to 2000. So then I would say, what is the overall percent change over the 2-year period from 1998 to 2000, and what's the cost per barrel in 2000? Okay. So to answer this, what we're going to do, if I can get this to go, there we go. So to answer this, what we're going to do is we're going to start with our equal sign, and we're going to do equal to, parentheses, 1 minus 28%, close parentheses, times, parentheses, 1 plus, because we increased 106%, 106%, and then all minus 1. Oops, that's not the minus sign. All minus 1. And when we hit enter, we're going to end up with an overall 48.32% change from 1998 to 2000. Now we know that in 1998, the cost was $15.38 a barrel. If I can get this to go back. So we know that the cost was $15.38 a barrel. So what we can do is we can use the simple percent change formula and take equal to 15.38. Oops. 15.38 times, parentheses, 1 plus 0.4832. And that tells us that the cost per barrel in 2000 was $22.81. Okay. So that concludes the web lecture for Successive Percent Change. There's a short one. Work on your activities during the week and bring any questions that you have to class. There'll be plenty of time for that when we meet next. Also, take a look over the Stage 2 document that is on D2L. We will also be working on that in class when we meet again.